problem 3.140 are you adopt? A point charge Q is located at the center O of a spherical uncharged conducting layer. So I draw it like this. Well, and provided with a small orifice, the inside and outside radii of the layer are equal to A and B respectively. So this is A and this is B. This is a conductor. Think like a conducting cell of inner radius A and outer radius B. And the question is, what amount of work has to perform to slowly transfer the charge Q from point O through the orifice and into infinity. So how much work is required to bring the charge Q from center to infinity through this orifice? So how you will do this question? Say the system possesses some energy, because you know there is a charge Q, and by induction the inner surface will attend a charge minus Q. That you know well from the Gauss law. Facing surface will have equal and opposite charge. So this is Q, so this will be minus Q. And since this conductor is neutral initially, and we know the charge cannot reside inside it, only on the outer surface or inner surface, means the surface. So the other possibility is if it is minus Q, then there must be plus Q, which will be on its outer surface. So this is plus Q charge. Now, then since there are charge configuration in this system, Q, minus Q and plus Q, so there will be potential energy of the system. You know, already we have discussed the potential energy, that is the self and mutual potential energy, and we can apply here the self and mutual potential energy concept, because that, and by this we can get the work done to bring the charge particle from center to infinity. We know this thing from work energy theorem. What is work energy theorem? You know, work done by external plus work done by conservative plus work done by non-conservative is equal to change in kinetic energy delta K. There is no non-conservative here, so it will be 0. So work done by external is equal to delta K plus minus of work done by conservative, and we know minus of work done by conservative is nothing but change in potential energy delta E. Moreover, we have to bring the charge particle slowly from center to infinity. So delta K is also 0. So only thing left is work done by external agent is equal to delta U. And delta U means U final minus U initial. And we know as we bring this charge particle from center to infinity, no charge will be here. So there will be no induced charge here or here. So there is no energy of the system. Moreover, conductor is here and charge particle Q will be at infinity. So therefore, there is no mutual energy also. So we can say finally the potential energy of the system will be 0. So U finally is 0. So only thing left is then minus of U initial. So whatever the initial potential energy of the system, we multiply with minus sign and we will get the work done required to bring the charge particle. So let us calculate what will be the potential energy possessed by this system. Well, I will do it here. We know potential energy in case of electrostatics, it will be mutual and self. Already we have gone through this. Mutual, you know, Q1 and Q2 separated by R. Mutual potential energy U12 is 1 by 4 pi epsilon naught Q1 Q2 by R. Self is, due to its own charge configuration, it is defined for object, charge object, not for point charge. We have already calculated for cell, metal cell, charge Q on its surface, the self potential energy is 1 by 8 pi epsilon naught q square by r. That already you know. Let us apply this concept here and do this problem. So come here. Your initial potential energy is the potential energy between O and inner surface I write 1, outer surface I write 2. So I will say that it is a mutual potential energy between O and 1, mutual between O and 2, mutual between 1 and 2, self of 1 plus self of 2. And we should remember the self energy is always positive because it is q square. That we should know, and mutual may be positive, may be negative. It depends for like charges or unlike charges. Anyway, U, O and 1 will be what? 1 by 4 pi epsilon naught, and Q minus Q by A. O and 2 will be 1 by 4 pi epsilon naught Q into Q by B, and 1 and 2 will be, we can think that minus Q is at center to find the potential outside the radius A. So the potential for minus Q here will be 1 by 4 pi epsilon naught minus Q by B multiplied with plus Q charge will give the potential energy between 1 and 2. That you know. So we can say 1 by 4 pi epsilon naught minus Q by B into Q. And then let us calculate the self energy. For inner one it will be minus Q square by 8 pi epsilon naught A, and outer one Q square by 8 pi epsilon naught B. Let us see what part is cancelled out. This is minus Q square by A, this is Q square by B, this is minus Q square by B. Oh well, this and this will be cut. So this minus Q square by B plus Q square by B. So this part and this part will be cut out. So it will be 1 by minus Q square by 4 pi epsilon naught A plus Q square by 8 pi epsilon naught A plus Q square by 8 pi epsilon naught B. So if I take 1 by 4 pi epsilon naught common, Q square by A, 1 by 4 pi epsilon naught A common, so it will be minus 1 plus 1 by 2, so it will be minus 1 by 2. So it will be Q square by 4 pi, Q square by 8 pi epsilon naught 1 by B minus 1 by A. So work done by external agent is minus of that U initial according to that formula. So it will be Q square by 8 pi epsilon naught 1 by A minus 1 by B. So I hope it is clear to everyone. Okay, fine. So this is how we will get it. Alright, this thing? Okay. So let us go for the next problem. If you have any doubt, we will take it. Okay.